Hello students, today we will discuss about prism, and in prism we will talk about refraction and dispersion through prism. These two topics we will discuss today. First of all, we should know what is prism. Prism is a device made up of transparent material. It can be a glass prism or it can be a plastic prism. But it should be transparent so that light can pass through the prism. It is a small device and it is having, as I have drawn here, it has 5 sides in total. So this is a triangular prism. And it has total 5 sides. Out of these 5, 2 are triangular and 3 are rectangular. So what are these sides? These 2, as you can see in this figure, 2 are triangular sides which are also known as triangular bases. This is a 3D structure of prism, but mostly we took 2-dimensional when we do certain experiments. So these 2 are 2 triangular sides, and the rectangular sides, these are, we can see, one is this is one of the rectangular sides, the other is this is the second rectangular side, and where is the third? Third is this is the third rectangular side. So we have 3 rectangular sides and 2 parallel triangular sides, and if light ray is incident on the prism, it will come out of the prism after deviation in a certain type, certain form. So the prism, we have learned the refraction through a rectangular slab, but here the refraction through a prism is different from that of a rectangular slab. So this is the 3D structure, and this angle which is present in between the 2 rectangular sides is known as angle of prism, and it is here. This angle is known as angle of prism. The prism, you can see, is somewhat like this. This may be the structure of prism, how this is one triangular side, this is the other triangular side, this is one rectangular side, this is the other rectangular side, and if this book has a base, then this base will be the third rectangular side. So in a 3D structure, this prism will look like somewhat like this. So this is about the prism. It is of glass or it may be of plastic. Now we will study refraction through the prism. Before studying through prism, we should know what is refraction of light. Very easy, all of us know that bending. If we want to define in a single word what is refraction of light, refraction of light is bending of light ray. But when this bending is there, if the ray is traveling through the air in this medium, there is no bending of light. Only the bending of light will be when a ray, it enters from one medium to the other medium which have different optical densities. What do we mean by different optical densities? That is, their refractive index is different. Density we all know, and optical density is different from the normal density, because optical density determines the bending of light. We have done this refraction of light in a rectangular slab. And what is this? If this is a rectangular slab and a light ray is incident. Incident means it is falling on this interface. This interface of this slab, this medium is air, suppose, and this slab is of glass. So this light ray, it enters from air to glass. So we call air as rare medium and glass as dense medium. Or if we compare, then we say rarer or denser medium. Glass is dense than the air. It has more optical density and it has higher refractive index than the air. So when this ray is incident inside a glass slab, what happened? It bends. That is, it refracts. Bending and refraction, one and the same thing. Why it bends? Because now the two mediums are different. In air, it travels straight, but when the medium change, then at this line, this is the interface of two medium. From air, it is entering the glass. So where should it shift? We have to draw a normal. Normal means that is a perpendicular line which is perpendicular to this interface. This normal, this incident light, this bends towards the normal. So this angle of incident will be bigger than this angle, which is angle of refraction. Is it clear to all of you? So this is angle of refraction and incident, and this angle is angle of refraction. Refraction is lesser in this case because the light is entering from rare to denser medium. It will shift, it will bend towards the normal. Now when it touches this interface, it will come out in the air. So this will be the denser medium. Now again it is coming to rare medium. So what will happen? Again, if we draw a normal, this line is known as normal and it is perpendicular to this interface. What will happen? This refracted ray, it will go away from the normal. That is, now this angle known as angle of emergence, it is bigger than this angle. And suppose there is no glass, there will not be any glass slab. And if this light, it is coming straight, so if there will be no glass, then this ray should come like this. But it is bending only due to the presence of this glass slab. First is shift towards the normal at this interface, and as it comes out, this is known as emergent ray. This ray is known as refracted ray. This ray is known as emergent ray, and we all have learnt this when we have done this glass slab refraction. So this is the emergent line, but ray. But normally, if there would not be any glass slab, then this line should go like this, straight. This ray should go like this. So this thing, this is a shift, and this is known as lateral displacement or lateral shift. So, and this emergent ray is parallel to this incident ray. So what we have seen in glass slab, that the emergent ray and this incident ray, they both are parallel to each other. Why they are parallel? Because these two interfaces, these are parallel to each other. So this incident and emergent ray, they are parallel to each other. Now we see what is there. Let us see if this light is coming through a prism. That is, now we will discuss refraction through a prism. So for this we will do an experiment in lab, a very simple experiment, and you carefully see what I am drawing on the board. So we have taken this prism and you have seen that I am taking only this triangular face of prism. When we do experiments, we draw on the paper, we do not take a three-dimensional. We take this type, and this interface is one of the rectangular surface. This interface is the other rectangular surface, and this triangular is the base of the prism. That when we do this experiment in our lab, we put the prism on one of the triangular surfaces. That is, triangular face is put on the table on a paper, and this will, we take the diagram like this. This surface is put on the paper and other surface they manage themselves. So these two triangular surfaces, the angle, as I have told you, in between them is the angle of prism. Suppose this prism is ABC. How we do this experiment? On a paper, on a white paper sheet, we put this prism and draw a line around this triangular base. And on a board, so this we put this prism, and on one side we put two pins. We fix two pins on one side. Suppose these pins are P and Q. And from this side, if we want to see their images, so light ray will come, it will fall on the prism, it will refract, and then it will come out from this side. So if we want to see the image of these two pins from this side, that is these two pins and the image of both the pins, they are in a straight line. So what will happen? Suppose we will see their images here. PQ, suppose the images are RNS. We fix two pins here, and where we see the image, we fix two pins here. Now we remove this prism from here, and with the help of a pencil and scale, we join these two lines up to the interface of the prism, up to this line of this is the base of the prism. So we extend this line up to here. This line touches this face at this point. So these are PQ, this is the image RS, and we join these two pins also like this. And now this is our incident ray and this is our emergent ray. And we join these two points like this. So what is this? These three rays are formed in this way. This first ray, it is known as incident ray. What ray? Suppose it cuts it into A, B, C, E. Here it is, suppose this point is E and this point is F. So this PE is the incident ray. It is falling on this side of the prism. Now this FS is the emergent ray. It is coming out of the prism. And this ray which we found by joining these two is EF. This EF, it is known as refracted ray. refracted ray, and this is emergent ray. So these three rays we have formed. Now I will draw the angles. First I will draw a normal on this point. Normal means this angle should be 90 degree. Suppose this angle normal is n dash. I will also draw this perpendicular normal on this point also, and this is the normal with interface. It should make a 90 degree angle. So two normals are formed. Now we will see what angles are there. Angle should always be, you remember this, angle should always will be between the ray and the normal, not with the interface. This line is interface between air and glass. So if we draw the angle, we have to draw three angles: angle of incident, angle of refraction, and angle of emergence. So three angles we will draw. So how will we draw these angles? These angles should be between the ray and the normal. So what will be the angle of emergence? This angle I should be the angle of emergence between this ray and between normal. Here also there is an angle here, but this is not the angle of incidence. It is touching this interface. No, this is wrong. So the angle is between ray and normal. The other angle between ray and normal is this angle, which is angle of refraction. And the third angle between normal and ray is this angle, which is angle of emergence. So these three angles are formed. So this is how we make this. We can measure these angles also. One important angle is left, and that is known as angle of deviation. Deviation means when this light falls on this interface, it is incident on prism, it deviates, it shifts its position, it changed its path. How it is deviating? Suppose this prism would not be there, then this ray which is coming like this should go straight like this. It is bending due to this prism. If there would be no prism, then this straight ray should go like this. And if there would be no prism, the bending, how much bending is there? This is how this ray is bended. From here to here, here to here, and here to here. So if we proceed this line like this, have you seen? I have proceeded this line further and I have proceeded this line backwards. So an angle here is formed in between these two lines, and this angle is known as angle D, which is angle of deviation. So this angle is angle D. This angle is angle D, which is in between this line, incident and emergent. And this is formed due to this prism. This incident ray deviated this much by this angle, or we can see by this angle. This angle is also the same angle of deviation. We can measure this also. In your exam, mostly this type of figure is there in the examination paper, and they sometimes they write these angles wrong, or they ask for this angle or this angle, and You have seen I have written here A, B, C, then E, F. I did not write D previously because I want to write D for this angle of deviation. So in this way, we know how much this incident ray is bending and at what angle this prism can bend this incident ray. This is one thing. Now the second thing, you have seen a difference from rectangular slab. There, this ray incident and emergent both are parallel to each other. Here, these are not parallel. They have at angle and this angle is angle of deviation. And the second thing, always the emergent ray, it bends towards the base of the prism. Base of this BC, it always turns down, bends towards the base. There in rectangular we have seen the lateral shift or lateral displacement. Here it is bending towards the base of the prism. So this is how the light or the light ray refracted through a glass prism which is rectangular. So this we can see by doing the experiment in lab. Now the second thing, you should draw this diagram and should label all the angles and all the rays. So there will be no confusion, and learn to draw both the normals N dash and M dash exactly perpendicular to these two lines. So some students, they wrongly form these perpendiculars. Suppose this is prism and this is the ray. So they draw how? Like this, or wrong drawing like this. They draw perpendicular like this, perpendicular to this base. No, this normal N dash, it should not be perpendicular to this base. This should be perpendicular at this point to this side, to this interface. So always draw a normal like this, which is perpendicular to this line, and this angle should be of 90 degrees. Likewise here also, don't draw it like this. It is wrong. So now coming to the next part, we will discuss about the dispersion. Dispersion of light by a prism. So what is dispersion? Dispersion is breaking the light in its constituents. So separating of lights in its constituents. All of us know that white light is made up of 7 colors. A spectrum of 7 colors is there, and this prism can disperse all the 7 colors separately of a white light. And its natural phenomena we see in the sky after a rainy day when sun is there. So both are needed, droplets in atmosphere is needed and sun is needed. Then we see a natural 7-colored rainbow in the sky. This is also dispersion of light by natural water drops in the air. So this is how we will see in lab that dispersion of light takes place by a prism, by a triangular prism. So what is the experiment done? Again, this prism, the figure is made taking only one phase, that is the triangular phase. So suppose this white light is incident again on this surface. What will happen? At this surface, This is rare medium, this is denser medium. So what will happen? This light white is made up of 7 colors. And what are the properties of these 7 colored rays? They have, the first property, they have different wavelengths. Wavelengths. So what are these 7 colors? All of us know it is, we can remember by this anagram, vibgyor. That is violet, indigo, blue, green, yellow, orange and red. So all these colored lights, they have different wavelengths. And what are the approximate wavelengths? Violet has minimum wavelength around 400 nm approximately, and red has maximum wavelength around 700 nanometer. So, and in between all these have from 400 to, it is about 730, sometimes 740, it is 390, 380 sometimes. So round about 400 to 700 different wavelengths of different color lights is there in this spectrum of white light. This is known as spectrum of white light, only white light, not the full light. The spectrum is quite long, but the spectrum of white light is known as, of 7 colors, vibgyor. So they have different wavelengths. So, and the second is, all the colors, that is the light of all the colors, it bends with different angles. What does it mean? It bends by different angles. We will just see what is this. And third, they have different speed in prism or glass. It should be S, not Z. I have written Z, I think. I don't know. It should be S, I think, not Z. So, what are the 3 properties of these different colored lights? They all have different wavelengths. All the colors band with different angle in glass. They have different speed in glass. So we will see what is this. So when this white light touches this interface, it breaks into 7 colors, and this is the dispersion of white light. And as I have written here, they band with different colors. So one of the colors, it bands like this, and the topmost color, it bands like this. This line is of red, this say is of red color, and this, the lowermost, is of violet color. And in between, other colors are, 7 colors are there. So this angle, suppose again I draw a normal. So the angle of violet is this much. The next indigo is this much. The next blue is this much. And red has the angle this much. So they bend by different colors with normal. Their angle of bending, angle of refraction. What is angle of bending? Angle of refraction is different. All the colors, they bend, they refract by different angles. So inside the prism, these are the different angles, and now these rays of 7 colors, they touch this surface of the prism, this interface of the prism. Now they come out from dense to rare medium. So what will they do? Suppose this is the, again I will draw a normal, and red I will again draw a normal. So what will happen? It is coming to rare medium. So this light, this violet color ray, it will go away from the normal. Here it bends towards the normal, it will go away from the normal. So all they go like this and they spread more like this. So all these, they go away from the normal and they spread like this, and we have a beautiful spectrum from violet to red color when the light, this white light, emerges out from this prism. This is known as dispersion of white light from prism. And you can see violet is bending most, red is bending least. One thing more you can see, the speed of red, it is least, and speed of violet, it is most, because it has less wavelength, so it will travel slow. It takes so much time from coming here to here, it will travel slow. The R or red, it has the highest wavelength, 700. So it comes to this side quickly. So the speed of red is most and speed of violet is least. So this is the dispersion of white light, and if we place, we can do it in lab, and if we place a screen here, the 7 colors can be seen on this screen, and this is known as spectrum of white light. First of all, this is seen by Newton. And Newton, what did he do? He want to know, what did he do? First he put again a prism in front of this prism. He want to know whether these 7 colors will disperse further. Can they break down further? But he saw that they are not breaking down further. They remain 7 to 7. So he did an experiment which is known as Newton's 2 prism experiment. And what he do? He put an inverted prism. An inverted, it should be close by, not very far. So he put an inverted prism in front of this prism. So these rays, they are coming to this prism on inverted, and again they are coming from rare to denser, so they will bend like this. They will bend on the same point and they will emerge out as a single ray, single color of light from this side. So these 7 colors, they again bend and they on a common point, and this, the emergent ray, is of white color. So what Newton, this is a Newton's 2 prism experiment to prove that white light is made up of 7 colors, and these 7 colors, first they are dispersed by this prism, and then these colors, they again form a single white colored ray. So this experiment shows that this white light is made up of 7 colors, and in a white ray, all the 7 colors, they are present so close to each other that human eye cannot deduce all the colors separately. It can be separated or dispersed by these prisms. So this is all for today. Thank you.